Good afternoon, everyone. Welcome and thank you for attending this Heat Map of Europe webinar. My name is John Kapetanakis, a member of the Heat Map of Europe team at Aalborg University in Denmark. We're hosting a series of webinars about the Heat Map of Europe project funded by the European Union. This is the 6th out of 8 webinars scheduled for this autumn and the 13th in total for 2018. At this round of webinars, we dive deeper into the latest results of the project, that is the Heating and Cooling Strategies, also known as HEAT Roadmaps. Today, Susana Paardekooper, PhD fellow at Aalborg University, a member of the modeling team of Heat Map of Europe, will present the main results about cooling from the recently published HEAT Roadmaps, the Heating and Cooling Strategies. Also, Pär Dalin from DEVCCO, a member of the Heat Map of Europe Advisory Board, will provide his reflections and some of his experience. If you have any questions or comments related to the presentation, please use the sidebar on the right of your screen to send it to us. We'll have some time to address this before the end of the session. Yeah, Susana, over to you.
And also for me, welcome. Before we start, you'll have to excuse me because I have a bit of a sore throat, so I might sound a little squeaky every now and then, but I'll try to work my way through it as best as we can. As John introduced me, my name is Susana Paardekooper, and I've worked on HEAT Roadmap Europe for the last 2.5 years. And today we'll be talking a little bit about the cooling element of this wider project. Before we start on that, it's worth having an overview of the general project. Hopefully many of you will be familiar with it. But to be able to contextualize what it is exactly about the cooling, we'll talk a little bit about the project in general, and then really zoom into the specific findings that we have for the cooling. So to start, we have a general purpose in HEAT Roadmap Europe, and that is to create scientific evidence in the form of data, methodologies, tools, and strategies to support the long-term development of a transition to a low-carbon energy system. And we do this by quantifying the impact of various alternatives. So we build different scenarios, we look at different options, and then from that we try to provide data and scenarios that can help have the discussion around heating and cooling, and in some ways democratize the debate so that we can talk about our alternatives in a more informed way. So that's the overall purpose. This is not something which we have never done before. What we're doing here in HEAT Roadmap Europe 4 is really the culmination of work that started as early as 2012, where there was a collaboration between Aalborg University and Consortium University and Euroheat and Power, who initiated the process to really start looking at what district heating could be like. Some of you may remember that around this time, the European Union set out an energy roadmap towards 2050. And that roadmap didn't include much space for district solutions. So that was the purpose of that investigation. Since then, we've really broadened out to look at heating and cooling in general, so also individualized solutions. But as you can see, as of 2015, also to start really looking at cooling, which has very long been an underrepresented part of the sector, and something that is being in many ways overpowered by heating as this discussion has started to take place, but which, as you'll see, is really not an insignificant part of the sector and not something which can be fully ignored. So that's why in this 4th iteration of the HEAT Roadmap Europe studies, we've looked at heating and cooling strategies for 14 countries in the European Union. And with that, we cover about 85 to 90% of the cooling demand in the European Union. So we hope that by providing the data for these 14 countries, we can also start having an informed discussion in the European Union about where we want to go with cooling. This slide shows all the organizations that have been involved in the HEAT Roadmap Europe 4 project. I won't discuss most of them in detail, but what I think the main point about this is that we've had a very large group of very committed people, and due to that, we've been able to create some really nice data. There's a lot of different backgrounds that are involved in the consortium. So there are some people who are very specific in different types of technologies. Pär, who's joining us today, is the person who knows a lot about district cooling in our consortium. And in the same way, we've had people like that for the built environment. We've had people like that for other resources like cogeneration, but also district heating and heat pumps. So we've really been able to build a bit of a coalition that involves all the players that are necessary in order to be able to understand such a broad topic in a lot of detail. And that's been one of the reasons that we've been able to really look at this cooling sector and build on the knowledge that has existed about it and bring some new and some interesting results for the future. So one of the a priori assumptions that we've had all along is really that heating is key to the energy system. And that's something that we've seen a lot, and which is held to be true. I mean, when we talk about heating and cooling in Europe, I think one of the reasons that cooling often is undermentioned is because heating is still a very big part of the system, and heating in and of itself doesn't really get enough attention. As you can see here, heating and cooling comprises about half of the energy system in Europe as it stands today. And while there are savings to be made in the heating sector, that trend continues. One of the other things we looked about is what is the share of heating and cooling in different countries? And we'll talk about that in more detail, but it's important to note that even in the countries where space cooling demands are relatively high, so we're talking about the southern countries like Italy, Spain, Portugal, there is still a level of heat demand. And even when we talk about the countries that are the few places where we can really talk about a domination of cooling, those are Cyprus, Malta, and Greece, there is still a heating demand there. So in addition to really being able to look at cooling in more detail, it's also important to note that heating is one of the main things that we have looked at in this project, because it is such a big and underrated part of the energy system. In terms of what we found, it's something which is not completely out of the expectations, which the findings that we've had in previous Hero My Peer projects, but we've done it with a lot more depth of understanding and in a lot more detail. The main finding, for me at least, is that we've really been able to show through the scenario development that it is possible to decarbonize the energy system and the heating and cooling system in line with kind of the political agreements that are being made in the Paris Agreement, using the technologies that we know today and that are used today. And that's an important point, because especially over the last few weeks and over the last few months with the new IPCC report, there's more and more the urge to do something, and it's becoming more and more of a necessity. So to know that we can build scenarios in which these things are feasible and possible and economically viable is an important contribution to make to the discussion when we talk about these kind of things. And that goes for both heating and for cooling. It's important to know that these things are possible and to continue to say that it is possible to decarbonize the sector. When we talk about how we do this, the diagram that you see to your right is probably familiar to many people, but worth reiterating. We find that it's necessary to have deep energy savings everywhere. So that goes for the built environment, but also for industry and the service sector where that's not built. And that is a non-geographical thing. So it is worth doing energy savings, both in urban areas and in rural areas. When we talk about urban areas, then district energy networks, including district cooling networks, are a very good solution to really be able to capitalize on the efficiency that they bring to the overall system. And we come close to about 50% of the energy demand for heating when we talk about district heating systems. And we'll talk in more detail again about the district cooling systems. It's not as much, but it's important to be able to capitalize on the areas where there is a high amount of density in order to be able to bring that efficiency to the table. For rural areas, for heating, we look mainly towards heat pumps because they are efficient. And that goes for cooling as well. A lot of individual cooling can be very efficient and should be very efficient in order to be able to minimize the impact on the energy system and be able to contribute to that decarbonization that we have. Within all of this, there's been a very important element of having these heat roadmaps grounded in the wider energy system. So looking also at the electricity sector and also at the transport and industry sectors. For cooling, that's not really a revelation, because I think that the analysis that has happened around cooling has always been very integrated with the electricity sector because it is so embedded in it. I mean, the problem has always been that cooling has been hidden in the power sector. So that's not such a new thing to bring to the table, but for heating especially, that's something which is really important. And as we've done the analysis, has really showed to be an important part of the approach that we've taken in these heat roadmaps. So when we talk about the overall findings of the project, there are some general trends that are in this diagram. I know it's not the easiest diagram, but it is a good way of summarizing what we found. When we redesign the heating and the cooling sector and then take into account the changes that happen within a decarbonized transport sector and industry sector. So the first thing to note is that we can reduce overall primary energy supply in the heat roadmap scenarios that we've developed. You can see that represented in these kind of blue-gray circles. And the reduction in that as we move from this baseline in 2015, which is basically the situation as it was a few years ago, towards the HRE scenarios in 2050. The other thing to note is that as we move towards a decarbonized future, there's a very high level of electrification. So we haven't radically redesigned anything compared to conventional decarbonization approaches, but we see a higher level of electrification in transport. We see a higher level of electrification in industry where that's possible. And then in order to be able to provide a lot of fuels in those sectors where electrification is not possible, we see the emergence of a lot of power to gas and power to fuel and kind of indirect electrification of those sectors. So you can see that the electricity supply, which is denoted by the kind of dotted line that goes around the middle section, is hugely expanded. And that is not only because of the power sector, but also because of the changes that happen in the other sectors. There's a much higher level of renewables, and particularly variable renewables, in the electricity sector. And that is partially made possible by an expanded district heating supply. So by increasing the district heating supply and really playing with the different ways in which we supply the heat there, we can bring in a much higher level of both flexible power production in the form of CHP, but also through heat pumps, particularly, be able to really bring the flexibility and the availability for those variable renewables into place. So this is a bit of an overview of the general results that we've had in heat roadmap here, to give you some background. To talk specifically about the methodology, this becomes important as we start talking about how we approached cooling in the heat roadmap Europe project. We spent a lot of time really specifically looking at what the heating demands are, where the heating demands are, and then what the energy system potential is. And we've done this for cooling as well. So we've looked at what kinds of cooling demands there are, where those cooling demands are geographically, and then put them in. In terms of the buildings and the industry, which includes the service sector, we've done a lot of modeling and forecast. Our partners in Fraunhofer have worked with us a lot, and they've worked with our mines to look specifically at the cooling demands in terms of where they are in the built environment, how much of it is in the built environment, what happens in the service sector, and partially what happens in industry when it comes to really being able to define and, I mean, I don't want to say forecast because but to project what kinds of cooling demands we'll have. And that in itself is an important contribution because that's something which has happened before, but is overall much less certain than for other sectors such as heating. In terms of the mapping, PETA has given us the district heating potential, but also given an indication of what the distribution costs would be for district cooling systems. So by being able to geographically locate a lot of the cooling demands, we can start looking at what the costs would be to connect that up with pipes, basically. And that can then all be combined in this energy system potential modeling. So again, to really zoom in on the cooling, for the cooling, one of the main things that's been important is to look both at the residential sector and at the service sector. We know that cooling is something which is more heavily used in the service sector than necessarily in the residential sector. And similarly for industry, it's an area where we know that cooling is very important. For the energy mapping, we'll talk about that and I'll show you an example in a minute, but it's been a challenge if we compare it to different types of mapping that we do to really be able to look at where the cooling is. For the energy system modeling, one of the things that we've had to do in HE Roadmap Europe is really develop cooling specific technology data sheets, because the knowledge on what kinds of technologies are available to supply cooling and at what kind of cost and with what kind of efficiency they exist now and they will exist in the future is something which is both developing very quickly, so a lot of the data that there is may not necessarily be up to date, and something which was really important to do in order to be able to do that energy system analysis. And then again, it's been very important there to be able to link the ways in which we can use different types of excess heat so that we can, use absorption to turn them into cooling, but also electricity to ensure that we take those elements of the cooling into account. So in terms of cooling demands, which is the first thing that we'll talk about in terms of the specific results, we've basically developed these using a model because it's, again, something which is less certain than it necessarily is for the heating sector, which is what we normally kind of compare to. For the service sector, we've based the analysis and the projections towards the future on the levels of saturation that we can observe in the United States. This is basically chosen as a best practice case where we know that saturation levels are high, and we can build scenarios on what cooling demands would be under the assumption that those are the saturation levels that we would reach as well. Those are, of course, climate adjusted. One of the things that we've done in HE Roadmap Europe, which was something that we discussed, is we've taken into account the climate changes that are predicted as we move towards 2050. So as we know that Europe will get slightly warmer, we've taken that into account when we start looking at what the cooling demand projections are. For the residential sector, we've done something similar. Here we've also looked at what the saturation levels are in the US, because we consider that to be a very mature market. But we've also looked at different levels of income when we've started looking at saturation rates there. And again, it's based on a function of the climate, so of the cooling degree days when we look at that. That gives you, for the residential sector, the overview that you see below. And what we see there is that in basically all the countries, there is an increase, and in many countries, a very significant increase in the cooling demands that we see in the residential sector. And that is mostly due to really this increased uptake of cooling demands that already exist, but that are currently going unfulfilled. The largest increase that we see is in Hungary. And then in some other countries, there's a less radical increase, but still, very significant levels of uptake. I mean, the lowest that we find is almost 50%. You can see that one in Belgium. It should be the second one from your left. So these are really kind of radical changes. I mean, a doubling of the cooling demands in almost all the countries is really not something that is insignificant and something that can be ignored. And as we talk about the residential sector, that becomes important because it's not something that is traditionally as well developed with district cooling as the service sector, where we see the market be a little bit more mature and a little bit more saturated. To give you the overview of the service sector, it's easiest to show that in comparison with the other sectors that we have. So what you see on this graph here is basically all the different types of energy demands in the heating and cooling sector in the baseline scenario to your left, and then in what we call the 2050 baseline, so without any additional changes, but the one to focus on furthest to your right is the HE Roadmap Europe scenario. The bottom, the dark green there, is process cooling, and the top one is, or the light blue one, the top cooling one, is space cooling. And the note there is that process cooling is very significant. It doesn't grow as fast as the residential cooling does. The residential cooling consists mostly of space cooling, but it is very significant to see that it increases. And this was for us a bit of a surprise, because we looked a lot at the different types of energy efficiency measures on the demand side that can be made for process cooling, and actually implemented a lot of those. But regardless, there's an increase in the process cooling that occurs. So overall, we see a real growth if you compare the baseline 2015 with the heat roadmap Europe scenario in the cooling demands. In the other parts of the graph, you can see the heating demands. And as you can see, those decrease quite substantially, particularly for space cooling. So that means that when we move towards 2050, we also see that the cooling starts proportionally representing a fairly large part of the sector. So we're talking about 20% of the heating and cooling sector. This is not necessarily a domination of the sector. I mean, I think it's fair to say that the sector is still dominated by heating and cooling, and again, that space heating plays a very large role. But it does mean that cooling is not insignificant. If it represents a fifth of the sector, then that is a significant part of what is going on. And as we talk about its decarbonization, we really need to pay attention to how we do that and be able to create the data and the models and the methods to be able to address that sector. So to wrap up on the different cooling demands, what I've shown you here has typically been the aggregation of the 14 European countries that we analyzed. There is, of course, some variation between the countries. I've shown you here Spain and Sweden, which are pretty much the extremes from the countries that we looked at. And it's interesting to note that space cooling rather exists everywhere. So even in Sweden, there is a level of space cooling. But of course, this is very different in different places. So in Spain, you can really see that it's very large and that actually the space cooling is larger than the space heating. At the same time, again, there is no country that we looked at where there is more cooling demand than there is heating demand. So in that sense, there are differences, but the overall trends are relatively similar. What we see when we compare across the countries as well is that the service sector cooling is much less climate variable. So when we're talking about process cooling, really in industrial processes, but also about where the residential cooling demand is, where the space cooling demand in the service sector is, then the variability across climates of that is lower than the residential cooling demand, which is really the one that changes the most as you move towards or move through different climate zones. So hopefully that gives you a bit of insight into the work that was done to look at the cooling demands and the ways in which we've created the scenarios for these different cooling demands. In terms of then distributing those onto a map, that's been the second thing that we've really done within this project. And if you haven't seen or heard of PETA before, then I'd highly encourage you to go have a look at the website and browse around it yourself. Basically, in the Pan-European Thermal Atlas, we have worked with the consortium of partners to be able to map where the different types of heating and cooling demands are and where the different types of heating and cooling resources are. So the example that you see here on the slide is the spread of cooling demands around Madrid, around the capital of Spain. And that shows you effectively the density of the different, or of the cooling demand. It's important to note here that the methodologies that we've developed within PETA, which has been, in co-development with the Heat Roadmap Europe project since 2012, are a little bit different than for the heating sector than they are for the cooling sector. It's a top-down approach. So basically we take aggregated statistics at a national level or at a regional level, and then distribute those using a regression-based analysis. And when we look at cooling, because it is in many ways much more based in the service sector than necessarily in the residential sector, this means that regression has to be different and that analysis has to be different. Because the role of, for example, population, which is a big driver of the heating demand, isn't as large, because we're really also talking about service sector, where the map is not going to show that anyone lives there. So there's some methodological differences there, and it's important to note that this has been a much bigger challenge than the mapping of heating, and something where there is a lot more work to be done in the future to be able to build these kind of top-down maps. The reason why these types of maps are very important, to me at least, is that they can really start showing at a first glance where there are opportunities to look at collective solutions, so where there are opportunities to start looking at district cooling, especially since we often talk about how cooling demand is hidden in the power sector. So it's often very difficult to get local data on what the cooling demands are in different areas. This is also something which, building operators may have very good knowledge about, but is not necessarily available at a planning level. The PETA maps can really give a good indication of where there are priority areas and where there are opportunities to expand those priority areas. So this is something worth looking at. As I mentioned, this is also the way in which we have created the cost curves for the distribution of cold, for the distribution of thermal energy, because we can spatially locate where these different demands are and where the different types of resources could be. We can basically know the distance and the capacities that are necessary. So at a very aggregated level, we can start understanding what it would cost to build these pipe networks. And that's then what we've taken forward. So that's the function of the maps. And again, if you haven't seen them, it's worth having a look at. It's super interesting to also look at places that you know and places that you're more familiar with, because it has this top-down approach. And it's been one of the ways in which we can include solutions like district cooling into the energy system analysis. I mentioned this before, but one of the main things that we've had to do in this project to really be able to do the energy system analysis is develop some specific technology data sheets. To do this, we've worked with R-Minds, who are very knowledgeable on these things and have really worked also with the different types of eco-design developments that have happened over the many years. So that's something that we've used as we've been able to make the scenarios. I won't go into them because, no surprise, they're called technology data sheets and they're fairly technical, but it's worth having a look at if this is something which interests you. The format is very much inspired by the Danish Energy Agency technology data sheets. So if you're familiar with those, then you have a good idea of what you can use them for. But effectively, they show what the efficiencies of different technologies are, what the costs of different technologies are, how they work. So kind of a brief description of what it is that they do and what makes them different from the other technologies that are available. And then projects those forwards into the future. So projects towards 2050, which is based on both a stock analysis that they did, but also the kind of current policies that are in place that are there to encourage efficiency in cooling. So this has been really important for us to both understand what the situation is in 2015 to be able to make these baselines, but also to look at what the situation would be in 2050 and to be able to make those scenarios there. One of the things that's noticeable about them is that cooling can be very efficient. When we look at 2050, then in the end, the scenarios that we've developed, sometimes the COPs are as high as 8, but we're looking at an overall average of something like 6.6. So especially when it's compared to heating, where we're really, we talk about an efficient gas boiler as being maybe something like 95% efficient. Cooling is really quite efficient in comparison to that. So the development that we see in cooling is really already something that we don't understand well enough, but somewhere where the efficiency is already relatively high. So we're really looking to enhance that efficiency more than it already is. But there's definitely no reason to despair about the absolute inefficiency of cooling in many ways. Again, if you're interested in more about this, then these technology data sheets are on the website and you can find them and have a look at them. That brings us effectively to the results of our energy system analysis. For cooling specifically, the main result that we got out of that was the district cooling. So we combined all these inputs, both on the demand side, on the different ways that we can look at district solutions for cooling, so effectively use this kind of distribution cost for the pipes, and then the different technologies that are available in order to fulfill that cooling demand, and put that into the energy system analysis. From that, we found a certain level of space cooling that we modeled. When we look at the way that we've constructed this scenario, because of some of the methodological challenges that we have with the cooling, it's not really as clear-cut as the heating. So the recommendations that we can make on this level are really a lot less strong. But at the same time, there is a lot of things that we have seen. when we look at district cooling, we really see that there is a clear energy efficient argument. What we modeled didn't overly rely on free cooling, because this is something which is very difficult to map and something where the potential is very difficult to estimate from a national level. So we relied mostly on centralized chillers and the use of sorption cooling. But even then, we see a very high efficiency argument, especially for urban areas. The economic argument from a socioeconomic perspective is less strong. So we didn't find a huge variability in this. But again, that may also have to do with the fact that the data is just a lot less strong and not as developed as it is for heating. It's a lot of the work that we've done ourselves, and it's very difficult to kind of reference that and validate that. So it's difficult to really make a clear conclusion on that. But it is very possible to say from the results that we have that there is an energy efficiency argument for district cooling, even if we use technologies like centralized chillers and sorption, and we don't overly rely on using cooling from lakes and from rivers and those kind of things. The third thing that comes out of this is that we found a very large role for short-term storage. So especially as we start seeing that stronger interlinkage with the electricity sector, particularly through the centralized chillers, then the kind of 12-hour storage makes a real difference in the operation of them and really being able to use electricity when there is a lot of it there, for example, in the high wind hours, but also in the high sun hours, to then store that in a thermal format and be able to use the renewables when they are available. And that's one of the ways in which we can really create that flexibility that allows for a high level of variable renewables in the overall scenarios. So those are the three things that kind of jump out when we look specifically at what we find for district cooling in the energy system analysis. The graph that you see at the bottom is basically the level of district cooling. In the analysis, we looked at about 20% of the urban areas to be covered by district cooling. Again, because it was very difficult to find really a cost optimal, this was a heuristic approach that we went with that we would like to refine in the future, but it's something that at least allows us to project a scenario in which we have a role for district cooling without necessarily over or underestimating it. Because we're looking at urban areas, that means that the percentages overall change. What we see is that in the countries where you would expect a very high level of cooling, we see the highest levels. So Italy and Spain immediately jump out. Romania and Hungary are relatively high just because of the climate zone. They have high temperatures in the summer, and that's really when we see the cooling demand spike. The other interesting thing to note here is that because we're looking at urban areas, really large cities have an advantage. So Romania, in the district heating analysis, didn't necessarily have a very large potential, primarily because the way that the spatial distribution of the demands is that Bucharest is a very large city, but the rest of the country is in many ways very rural. And that means that for the district heating analysis, there wasn't a lot of growth potential for district heating in Romania. But when we look at district cooling, that same element also means that Bucharest is a very large city, and there we see a real potential to be able to expand district cooling. So in those ways, the results that we saw for the cooling in terms of the district solution, so for district cooling versus district heating, are in some ways very similar, but are also different based on the different drivers that these developments have. For all of these countries, we have a country-specific report where we also describe it in a little bit more kind of disaggregated detail for each country, how it works. So that's worth looking at for the specific countries that you may be interested in, or the ones where you live or where you work. So based on that, I hope that we've been able to give you an overview of the results that we found for cooling in the Heat Roadmap Europe projects. It's been something where we've really been able to develop a lot more of the data and the methodologies than we had before, and really been able to improve on a lot of the methodologies that we started pioneering in Heat Roadmap Europe 3 and Stratego. But at the same time, it's very obvious that it's an area where there is a lot more to be done, and it's not received the same level of attention as heating has. So there are a lot of gaps in the knowledge to be filled, and there are a lot of interesting things to be able to do as we move forward in this kind of area of research. I'm going to hand over to Pär after this, so that we can really start looking at these findings within the context of what is happening on the ground. One of the nice things about Heat Roadmap Europe is that we take a very large view and we look at these 14 countries and those kind of things. But at the same time, sometimes it feels a bit removed from the kind of city level developments that are taking. So Pär will talk a little bit about the best practices that we have and the way that district cooling fits in with the KIGALI agreements. As I think I implicitly mentioned, Heat Roadmap Europe started in 2016, so this is not something that we've been able to deal with. But it is something which is very important for the cooling sector and really something which has a chance to move it forward. So it's worth discussing. And then also some of the particularities about the district cooling development and its nature and its differences from district heating. So that'll hopefully provide you with the grounding of these results that takes place and the way that we can look at them. So with that.
Thank you, Susana, for your presentation. And I'd like to invite Pär to...
Yes, thank you, Jon. Well, as Susana said, there is still a lot to do on the cooling side, since it was the first time entering into the heat roadmap now on the 4th version. And I will take it a little bit from another angle, and starting with a few of the drivers, which we can summarize at the end, and starting with the overall picture of what's happening on the global arena is that in November 2016, where the decision was taken to do the KIGALI amendment to the Montreal Protocol, which means that there will be a global phase out of the existing refrigerants. Then I'm not talking about the natural refrigerants as ammonia, is the blends. So the Montreal Protocol that was established to phase out these chlor-based refrigerants that was well, killing our ozone layer. Now it shows that they are extremely CO2, has a big impact on CO2. And according to the well, analysis from a UN macro perspective, is that half a degree of global warming in the 2100 perspective is due to leakage of HFCs. So now when we have a global banning, and that comes quicker than we expected, prices of the existing refrigerants have increased by 3 to 10 times on the last year. The impact is half a degree from the phase out of these refrigerants, and the second part of it, that due to going for another technology and more system integrated perspective, there is also potential up to half a degree from the energy efficiency perspective. These are UN statements, and they also state that there is a potential of covering space cooling up to 25%. I should not sign on to that. I think from a Europe perspective and the old EcoHeatCool studies that were done some years ago, there is a financially feasible level of 25%. And coming to that, since I'm working for the whole European community, we of course look also at the Sweden, which I think we need to refine a little on the statistics here, because we have a market share today for district cooling, from the space cooling, for over 25% today. With that, it is about 30% of the district cooling in Europe. This is a little bit about energy efficiency. Well, as Susana said earlier, we can probably have an ideal situation, but from cooling from CUP on 6.6, which is sometimes a little bit different from what actually is the seasonal energy efficiency, which today on existing systems are about 2.5 when you look over a year. And here is a little table of what these systems can do. If we have the reference, well, existing equipment that is the baseline, we can see that just doing centralization like they've done in the biggest system globally in Qatar, it's at the same time twice as efficient. The Swedish systems that are in the middle here are in between 3 and 6 times more efficient. And that is, of course, a big driver for district cooling. And we also see that has an impact also on cutting the electricity peak, especially now when with much more data centers and electrification of cars. This is also a method of cutting power peaks. And we can see then the extreme, which is the Maldives project that we hopefully get in the ground, is well, the pure seawater air conditioning, which means going down 800 meters and bringing up 4 degrees water, where you have an efficiency of that is 10 times existing equipment, which will of course have a big impact, but huge investments. So it's a little bit about the we can see the big systems, the Swedish ones, Helsinki, Amsterdam, Vienna in the middle here, they are in about the same level of about 4 to 5 times more efficient. So we can switch to the next one, Susana. Well, here we have one example of in Sweden. Then it's the city of Linköping, which why I'm highlighting it is because it's one of the it's Linköping, and it's the system in Copenhagen that we can say is fully compliant with the KIGALI, which means that it's no HFCs in the systems. And this has been developing over the years, and I would say why Sweden is maybe the front runner here is the big reason for it is that we took an earlier decision on phasing out the old nasty refrigerants, CFC and HCFCs, about 8 years before Europe. And that was actually the starting point of district cooling in Sweden. And we can also see that in this case, it's a mix between free cooling, which is in this case more than 25%. It's absorption, and it's compressor cooling. That brings it up to a seasonal system of over 10. I think they are up, actually, the latest I heard, up on 12.5. So compared to 2.5, which is the average from the measurements that has been done, we can see that it is at least 5 times more efficient. So we can switch to, well, we can bring that one. So what I want to say is that, and that is the difficulty of mapping cooling, is that we can see in the city of Stockholm, a typical office building has as much heating usage in the year as cooling. Even if we are up on the high level of Europe as Sweden. So insulation of buildings is of course also a reason for it creates more than not temperature-based cooling. So we can also see that in a district cooling system in Sweden, about half of the cooling need is not directly coming from the temperature. It's internal loads and the servers and things like that. That is of course hard to map from a holistic perspective. So totally, we can say drivers, refrigerants, phase out, energy efficiency, cutting electricity peaks, and I should add that from a perspective of the utilities in Sweden, cooling is extremely important to be a full service provider towards their client or customers. So it should not be underestimated, and I can see also that in many cases district cooling is maybe the entrance also to the district heating business. Cooling is in a city center very much business to business, but from there it grows to well, the total sector, and which means that heating at the end is much bigger, but cooling can be from an entrance point extremely important, and also from a financial perspective, a way of getting the both products into the market. So that was some of the parts from my side.
Thank you, Pär. Thank you very much. Susana, is there anything that you would like to add on this, or we can just pass on the questions coming from the audience?
Yeah, I think we have some general conclusions on the screen, which is basically a summary of what we talked about. I mean, in many ways, it boils down to the fact that cooling is not an insignificant part of the heating and the cooling sector. We see a very large growth in the development of the cooling sector in Europe. And the efficiency argument is there. And district cooling can be a viable alternative and something which can be developed in different areas. I just had a quick look at the questions, and Pär, I think they're mostly for you. So
Okay.
hopefully we can move on through them and give some more information about the different things. Some of the questions are about when basically the development of the LINKÖPING system, how the costs to the consumer are worked through, and then also what the capacity utilization factors are and what the different types of payback for it are. So I think a little bit more information about the system itself and the way that it developed would be nice. Hopefully we can answer a few questions in one go there.
Yeah, to get an answer on if I understood it first, it's about how to introduce and what has actually happened over the how to introduce, and I think that is a very important question, and we can say in all successful implementation it has always started on a well in a phasing perspective, starting in a small hub, growing. It's very similar to heating, but that's normally how these systems. I can when I was managing the Stockholm system, when we were growing that in the late 90s, we had about 13 local systems before we integrated into one big one. So that is, from a financial point of view, extremely important. So that was one. And
the second was also about how the costs to the consumer are worked through and how that contributes to the business model that you have.
Yeah, we can say that that's what I'm doing right now when I'm looking back on the Swedish system now, some years later. We can say they are in different maturity. In an introduction phase, well, having alternative pricing model is necessary because every customer is different. So that means that you need to do investigations on the client side. What is actually the cost? And when you start that type of discussion, the customer always believe that the costs are about half of what they really are. So because cooling is hidden in the electricity bill. But investigation, getting a price model that is transparent to also the cost side of introducing a district cooling system, which means that need to play around with access fees, capacity fees, and energy fees. So it's as transparent as possible to actually the capex and the opex allocation you have to the project. So starting with an alternative pricing model. So just as an example, in Stockholm, when we started, we had a price model that was about 10% lower price than the alternative price. When we were calculating, it was like we were a little bit better. After about 2 years, we saw that the price acceptance price was about 10% higher, and that was due to indirect impacts with how they could change their staffing of the buildings and so on. So there are hard values and there are soft values to it. So that is one. But we can also see that later in when the business is more and more mature, there is a tendency of going over to tariffs, because it's hard to have like a couple of hundred of customers with different contract models. So in the beginning, strongly advised to have alternative pricing as the entrance to get it going. Over time, it can be okay to go over to more of a tariff or that more like the district heating pricing model.
Okay. I think that there's another question which is also about Linköping, but maybe also relevant for other areas of Sweden. There's a question about the different capacity utilization factors, and then also a question about the influence of the internal loads and how these change throughout the year, and what the differences are between the cooling season, which is 3 or 4 months, and then the other seasons.
Yeah, well, if we look at the simultaneity factor, it's in a typical city, when you come and you calculate the capacity installed in the city and the capacity you need in the district cooling to catch up with that, it's about half. And that's due to redundancy and also that the price model gives you more an incentive of running your system a little bit different, and also that not all buildings are having the peak at the same time. So there are simultaneous factors on the building level down to the system level. So it's a huge difference. And that's maybe the reason for getting economy into district cooling, is that you maybe only have to invest half of what you otherwise would have done in each building on the production side. And well, if we say that the rest of the money you bury pipes and then you earn your money on the energy efficiency. It's a very simplified summary, but it looks like that pretty much everywhere you come. So that was from the capacity, and then it was the base load issue. We can also see on systems, if we compare like Paris and other systems, there is a base load in those systems, also in Helsinki. About 13 to 14% of the peak capacity is running on a low. So there is a year-round base load in these systems. Some over years it has decreased slightly due to that you've been looking at energy efficiency on the building level. But I would say that today most of the systems are between 9 and 14% as a base load all over the year.
I think as a follow-up question to this, just to give some explanation, we weren't able to, in Hero Map Europe, really look at the interaction and the interplay between what happens with cooling demands when we increase the level of the energy performance of the building. So when we implement more insulation or when we change out the windows to put in a higher quality, we haven't been able to model the interplay with that. But that's something which is, very much discussed. So when we relate that interaction with a higher quality of building in many different places, how does that affect the base load, and how do we relate these issues to each other?
Yes, Susana, I can comment on that. That of course, the extremely high level of requirements from the building code in Sweden has indirectly been, the consequence has been more cooling. So there is a question, where is the optimum of energy efficiency from a heating perspective on the building towards the total energy use? So that has definitely created more cooling loads.
Okay.
All right. Is there any other question from your side, Susana?
No, I think I'm okay. I think we've covered all of them, and if not, then you're very welcome to email us.
Yes,
exactly. I have the details here. There we go.
At this point, I would like to thank you, Susana, for your presentation. Thank you very much, Pär, for your participation. And thank you all for attending. We look forward to having you at our next webinar next week. That will be about the heating and cooling strategies for countries with underrated heat demand. The recording of today's webinar will be soon available on our website and the YouTube video. And you can visit our homepage to see the recent report about the heating and cooling strategies. And you can follow us on Twitter to stay updated. Have a nice afternoon. Thank you very much.